2014 Leaving Cert High Level Paper 2 Question 1 is trigonometry. You're given this triangle and you're given information about it. I've put the information on. AB is 120, BC is 134 and AC is 150, and you're asked to find the measure of the angle CBA, which is this one in here. So let's write out the cosine rule. You can see it's not the sine rule. We don't have any angles, so it's the cosine rule here. So A squared is equal to B squared plus C squared minus 2BC cos A. So we're looking for the angle. Now, we could call it the angle B because it's at B, but it doesn't really make a difference here. Once you have the knowledge of the cosine rule that this A here is the side opposite the angle that we're dealing with, you can just fill this information in. We could simplify it down and bring the B squared and C squared across and leave cos A on its own. Maybe we could do that mathematically. If I bring the 2BC cos A to the left, I'm going to get 2BC cos A is positive equals B squared plus C squared minus A squared. And to get cos A on its own, divide by 2BC. So cos A is equal to B squared plus C squared minus A squared over 2BC. Probably a little bit easier than putting all the big numbers in at the start. So the B and C connect the angle, these two. So I have my cos A is equal to 120 squared plus 134 squared minus 150 squared over twice 120 by 134. Now we can just type this into our calculator and then we can get the inverse to get the angle. So this is giving me the cos of A to be 0.306467, 0.306467,67661. Well, we don't need this many decimals, but we could round it off, but don't round off too early because it could mess up your 2 decimal places. So let's get the inverse of this. It comes out as 72.1535, 72.153. So 72.15 degrees is the angle A. Part 2 asks us to find the area of the triangle ABC, which you all know is a half AB sin C, where A and B connect the angle. So my A and B are 120 and 134. So a half 120 by 134 by the sine of the angle that we've just gotten, which is 72.15. To the nearest whole number, just type it into our calculator. 7652.9. So it's going to be 7653, and they're dealing in meters, so meters squared. Part B, you're given this diagram. A vertical mass DE is fixed at the circumcentre. So this is the knowledge we require here about the circumcentre of the triangle at D, so this point here. The mast is held in place by 3 taut cables, EA, EB and EC, and explain why the cables are equal in length. So the knowledge about the circumcentre is that it's equidistant from all the vertices. So DB, DC and AD are all equal in length. So we have 3 right angle triangles. So if I just take one of them, so I'll take EBD, so D at the bottom of the pole, E at the top, and B here. So this is the cable here, EB, this one. So this is X, and this is Y, and X and Y in all 3 triangles are equal as, and you can say here, the distance A to D, AD is equal to DB or BD, which is equal to CD, and ED is same in all 3. This was in the early days of Project Maths. They want you explaining stuff. I'll just write the number 3 if I can't write properly in all 3 triangles. Therefore, hypotenuse must be equal if the two straight sides are equal, or some version of this explanation. So circumcentre, equidistant from all three vertices. I'll just write that down as well. Circumcentre, equidistant from all three vertices. That's all that was asked in this question.